In this video, I want to work with some Excel files. So if you go to the web and you go to the American Institute of Steel Construction website, they have a Excel file that contains data about all the different shapes that steel manufacturers make. So I've downloaded that spreadsheet. Here, let me pull it over and let you look at it. So here I've got in the A column, I've got an identifier, and then it gives the description or designation of the particular steel member that I'm looking at. Over here is the weight, the cross-sectional area, the depth of the member, the thickness of the web, the width of the flange, the thickness of the flange, and then a bunch of other properties here, including section modulus and moment of inertia. So I'm going to work with that file in Mathcad. And the way I'm going to do it is that I'm going to create a variable that I call table, hit the shift colon, and now I'm going to open that Excel file. So I'm going to hit the read Excel and go to the browse. I'm going to find that file, which is right there, and then I'm going to open it. It defaults to all the rows and columns. So if I wanted to, I could click and drag and select the rows and columns that I want to work with, but I'm just going to open up the entire file and make that available to Mathcad. So here it is. It's a little bit past the borders. Let me make that a little bit smaller. So I'll go to Math Formatting, and then there we go. So now the Excel file is available in Mathcad for reading. So I'm going to start pulling out some of the data, and here's how I'm going to do that. I'm going to create a variable called section that I'm going to use to pull out the designation as a string. So I'm going to type in section, hit the shift colon sign, then we'll type in table, and now I'm going to hit the bracket symbol on my keyboard next to the letter P, and that drops me down into the index notation, and I'm going to type in I, comma, 1. Now I'm going to get an error message here because Mathcad doesn't know what I is, so let me give it an I. Let's say I is equal to 112. So now Mathcad knows what the I is, and if I click on that and hit equals, now it tells me that in row 1112, column 1 is equal to the string that says HP 18 by 135. So let me create some other variables here. So I'm going to create the variable W, which I will use to pull the weight out. And when I look at my spreadsheet over here, W is the 0, 1, is the second column from the left. So let me make that table, hit the little bracket that drops me down, and then I can type in I, comma, 2, hit equals, and that's what you would expect. An HP 18 by 135 has a weight of 135 pounds per foot. But notice that's just a number. I haven't given it any values because Excel didn't give it any values. So let me do that by multiplying that times pounds force per foot. And let me change my system here to USCS notations. And pounds force per foot. And now I'm in the right units. So let me do this for another couple of things. Let's take the area of steel, table I, comma, 3 times inches cubed. I'm sorry, inches squared. Okay, that's 39.9. Let's go for the depth of the member. That's going to be in length units, so I'm going to use it in inches. go for the thickness of the web. The I, 5 times inches. Let's go for B sub f, the thickness of the flange. I, 6. We'll multiply that times inches. Hit the equal sign. 17.8. Let's go for a couple, 3 or 4 more. The thickness of the flange. Table I, 7. This will be in inches also. Let's go for the stability K. Table I, 8 times inches. Let's go for the moment of inertia about the x-axis. I, 9. And that's going to be in terms of inches to the 4th power. And let me format that a little differently, make that a decimal. So I've got I sub x, one more, the section modulus. That's equal to table I, 10 times inches cubed. Mathcad thinks you're in gallons, but we're not. We're in cubic inches. So that's 251. Okay, so now I have pulled this data from that spreadsheet into Mathcad, and I can do all sorts of manipulations with this. We've actually created the Mathcad template that takes this information and figures out the compressive structural capacity of a pile. So I may finish that particular thing coming up. But now what I want to do is that I want to somehow collect this data and I want to send it to another Excel spreadsheet just as an example of how you would do that. Not necessarily because I need to do it for this particular example, but just to show you how to do it. And the thing about writing to Excel is that when you write to Excel, you do it in the form of a vector or a matrix. So if somehow or another I need to pull this information into a matrix or vector form, and then I can write it to Excel. So I could do this manually, but I'm going to kill 2 birds with 1 stone here, and I'm going to write a little program that will actually collect the data into a matrix and then send it to Excel. So let's write a program. So I'm going to call this, the name of this program, data dump, D-A-T-A-D-U-M-P, and then I'm going to hit Shift colon key, and now I'm ready to start programming. So to do that, I've got to tell it, Mathcad that, hey, I'm writing a program. So this is the little symbol that it uses to write that program. And again, there's some keywords that I can't just type in. I have to actually use this. So this is one of those, because it not only gives the command, but it also sets up the program for additional work. So when I hit the 4, now I've got a for loop set up here. So I'm already using the variable I. And the thing about programs is that if you use a variable outside the program, it recognizes what it is inside the program. So I don't want to use I because that'll screw up a lot of stuff. So let me use another index. Let's call that J. And I'm going to make that an element of the range from 0 to 10. So I need an operator up here. And it's this little operator, the range. This is a continuous range, or in this particular case, it would do integers. If I needed a range where I have step intervals, then I would use this little function, but here I need this one. So let me type that in, and then I put 10. Now, I just move my arrow or my mouse and go down to the next one. So what I'm going to do now is I'm going to create a vector, or sorry, well, it's a matrix, but a vector and a matrix kind of the same. I'm going to give it a variable I. And now in the program, you can't use equals. So if you want to assign a value to something in a program, you've got to go up and use this local assignment variable or operator. So I'm going to give that I'm going to assign the values of table I comma j to this vector. All right. So I'm going to hit my space bar until I get all this stuff selected. And then when I hit my enter key, now I am out of the for loop and I can do other things. So I'm going to go to my functions. I'm going to go to File Access, and I'm going to go to my Write Excel function. And it's got a lot of place for arguments. I won't need all these arguments, but I'll need some of them. The first argument that I need is, well, where is the file? So I'm going to put this as a string, which means it's in parentheses. So I'm going to give it location, and I'm going to name the file XLS, and I'm going to give it something to write, which in this case, I'm going to give it the vector that I just created. I'm going to do something a little different, though, in that I'm going to take the transpose of that I'm going to write, and then let me just delete the rest of the arguments that are not really needed. All right. So, and then the next thing I'm going to do is I'm going to return this particular part of the matrix or the vector, but I'm not going to put the transpose in, and I'll show you why that's different. So I should be ready to set this up. So if I click outside here and then go over to calculate and calculate, it should work. So let me go over and pull up that particular spreadsheet that I was working on. And there you can see that what Mathcad did was it opened up this spreadsheet that I created called test, and it put in as a transpose matrix. So Mathcad wants to do things as a column matrix. So when I told it to write it as the transpose of that, it puts it in as a row matrix. And then let me pull these variables out so that we can compare them. Okay. So here we go. So my index is 112. My section is an HP 18 by 135, which checks. The next number has a weight of 135, then 39.9, 17.5, 0.75, 17.8, 0.75, 1.938. Had a little, it has a default in there, so you can go into the Excel spreadsheet and change it. 2200 and then 251. So you can see it actually wrote these values correctly. Now, if I wanted to see what Excel did, and I had room on this particular sheet, I could hit my equal signs. Oops, sorry. Anywhere else except in the text. Okay, and so it gives me those values. And you can see that corresponds to what we actually read into the Mathcad spreadsheet and also what's in the Excel spreadsheet. So this is an example of how I read data from Excel into Mathcad, how I put that data into variables so that I could do further manipulation. Then I showed an example how I could write data to Excel from Mathcad. So if you needed to get a lot of data that was somebody had sent you in a CSV format or an Excel format, and you wanted to do some manipulations that was more complicated than probably what you could do in Excel, and you wanted to do something fairly quick, then this would be a good way to do it. And then if you want to also be able to write the output from your Mathcad template to Excel, well, this is how you do it. So if you go into the help file in the Mathcad, there's some additional information here, but I think this will give you the idea of how to do that and how to create a matrix so that it's able to be written into an Excel file.